Welcome to Unconventional Engineering. I'm Tom Costabile, and I'm here joined by my esteemed colleague, Jay Flores, once again for what I'm sure will be a fascinating episode.
We have a lot to cover today, so let's jump right in and introduce our guest. Throughout his career, his contributions to engineering, the military, and the space program have been extensive and notable. An inventor with over 100 patents to his name, most notably the Super Soaker water gun, he is the president and founder of Johnson Research and Development, as well as its affiliates, Johnson Energy Storage and JTech Energy. Please welcome to the show, Dr. Lonnie Johnson. Thanks for being here, Lonnie. How you doing?
I'm doing great. Thank you. Thank you for the opportunity to speak with you and your audience.
It's a pure pleasure, sir. You know, forever now that I can tell, and I can't wait to tell my grandson that I met the brilliance behind one of his favorite implements, the Super Soaker. So, Lonnie, when did your passion for science and inventing first appear?
Oh my goodness. I've been interested in engineering even before I knew it was engineering. You know, as a kid, I was always taking toys apart, my toys, my brothers and sisters' toys, and see what was inside. I learned to repair appliances around the house. Just as long as I can remember, I've been interested in making things. I would always have little side projects that I would start working on, building things. My favorite toy, of course, was an erector set. And then after that, you know, little plastic blocks. I don't think they called them Legos back then, but yeah, building stuff and making stuff, problem solving is what excites me.
It's interesting you mentioned that, Lonnie, is that my first project was taking apart my mother's grandfather clock. And then he put it back together and there were no spare parts. So what can we do to continue diversifying the field of engineering?
Yeah, that's a good question. You know, we have a robotics program here. We work with First Robotics. We have a STEM center where we have a virtual reality center. We have a esports arena here. Use that facility for esports, but primarily for teaching coding. And so we're very focused on expanding and introducing the kids' interest and stimulating their interest in STEM. Because a lot of kids, particularly within the inner city communities, see sports and entertainment as a way out, but realizing that you know, this is an area that can be just as exciting and certainly rewarding. You know, I like Dean Kamen's expression. You know, this is a sport where every kid can turn pro. It's really about getting them to realize that this is something that they can do. One of the advantages we have in having our teams here, we have about 8 teams at the FRC level, you know, and we take our teams into the areas and introduce, and we start get kids interested in STEM, and they see kids who look like them doing it, and that's a huge advantage that takes away a lot of the apprehensions about, you know, whether or not they could do this or not. In terms of, in general, the South and the challenges. You know, my approach to that is that, you know, get kids excited, get them to experience success. And once they experience and realize what they're capable of doing, it's not something you can take away from them. It's just a matter of being really, really aggressive in opening doors and letting them see what's possible. On a larger scale, you know, people talking about DEI, and there are a lot of issues around that these days, which to me is mind-boggling because we're in a situation where we're competing against the world. It was a time when, you know, America had a, you know, preeminence in technology and engineering, and we could take that for granted. But now, in a more competitive situation, we really need all hands on deck. And so the idea of, you know, not wasting minds, not letting them vegetate is more and more important these days. And I think we need to be as aggressive as we can in awakening and planting seeds and stimulating interest in STEM before they get this apprehension about this is something I can't do. So building that confidence is, I think, extremely important. And it's important not only for it being a good idea and making sure that we don't leave portions of our society behind, because, you know, when people can't contribute, they can become problem that can become a challenge. And so I think being inclusive is extremely important.
Yeah, I agree with you. You know, I grew up in New York City, and boys club taught me quite a lot in terms of collaboration. I still have friendships, almost 60 some years that we still met. Where did we meet? We're in the neighborhood and went to the boys club, and we were doing some stuff, and it's been amazing. The other part that I'm amazed at is your career. So Oak Ridge National Laboratory, U.S. Air Force, NASA. Um, Now that you've got people thinking about STEM, what type of projects did you work on?
That I work on then at Oak Ridge. I was actually, my first experience at a national laboratory was actually Savannah River Laboratory as a grad student at Tuskegee as a nuclear engineer working on my master's degree. That was an internship, um, a summer program, basically, doing computer modeling and simulation analysis, looking at plutonium fuel spheres. They produce plutonium there in those reactors. And these were spheres that literally glow hot in the dark. That was intriguing to me. And, looking at temperature profiles and heat temperature distributions in various environments. Then went to Oak Ridge National Laboratory after graduating from Tuskegee, working on high temperature gas cooled nuclear reactors. Again, modeling, simulation, predicting performance. My primary responsibility was the auxiliary core cooling system, which is a backup safety system. There I was, I graduated, I had my master's, and basically I finished ROTC, so I was waiting to be called to active duty in the Air Force. Met some people there who told some other people about my background who had been in the military. And when I got called to active duty, I was actually assigned to the what was then the Air Force Weapons Laboratory in Albuquerque. Little did I realize that I would see those plutonium fuel spheres again, because those were the fuel spheres that were used to power the Voyager spacecraft, the thermoelectric generators, using plutonium as a heat source. There I was doing orbit insertion analysis, and NASA had gone on record saying basically when the Titan 8 released the Centaur into orbit and it was getting ready to do its burn to relieve Earth's gravity, it would be on a trajectory where it would not re-enter Earth's atmosphere. And of course, my responsibility as a nuclear safety officer was looking at things that could go wrong, second guessing the engineers and so forth. And so I came up with a scenario whereby the spacecraft could re-enter the atmosphere. Having proven NASA wrong, they offered me a job at the Jet Propulsion Laboratory. And of course, that was intriguing because I felt that, as a safety officer, looking at things that could go wrong, risk analysis and so forth, I wanted to be on the other side of the fence where we actually designed the spacecraft so things would not go wrong. Mm-hmm. So I left the Air Force and went to work at JPL, and there I was on the the Galileo mission to Jupiter as the power systems engineer. Again, those same plutonium fuel spheres. Little did I know when I was first introduced to them that they would have such a significant impact on my professional career. But as a power systems engineer, doing trajectory analysis, looking at various phases of the mission to make sure that there was enough power for the spacecraft to accomplish all the tasks at different points in the mission, probe release, science acquisition, and so forth, and orbit insertion burns, those kind of scenarios. But also, we ran into a problem, and I was responsible for managing power distribution and so forth for all of the subsystems. And we had a problem where if the spacecraft, if there was a short circuit or something, a power failure that would cause the main power bus to go down, we had these capacitors on board that would keep power to the memory. Because the memories were volatile, if you lost power to the memory, then there would be no program or software for the spacecraft to recover. So everybody was concerned about these capacitors. You lose, the amount of energy available was very, very short. Batteries were not qualified for space. And so there was a lot of concern. So I came up with this memory keep alive power supply that would draw power from the isolation diodes from the RTGs This is all about everything gets isolated. You shut everything down, trying to clear the short circuit or whatever it had the power plugs down. So I came up with this idea, and a lot of my fellow engineers said, "Well, that won't work." And I told the chief engineer that, look, systems engineer, that these guys are going to say it won't work. And when they do say that to you, let me know. I'll go home and build one in my garage and bring it in and demonstrate it. so I basically goaded them into working on it. And we got it working. I actually had one of my coworkers actually come up to me and apologize and say, "Lonnie, I don't want to apologize to you for some of the things I was saying about your ideas." And I'm like, "Well, Pete, what did you say?" "Oh, he'd assumed that someone had told me, but they had not. So to this day, I don't know what he was saying about my idea." Since leaving, I got a lot of accolades for that idea. So I had an invention that went to another planet. I'm like, okay, I've arrived. I'm an engineer now, and decided that I'd learned some things, want to go back into the Air Force and share some of the knowledge there, because I was aware of some of the issues that the military was facing. So I was assigned to went back on active duty, was assigned to the Strategic Air Command, now Strike Command, but that was headquartered in Omaha, Nebraska. And I was on staff of this 4-star general who was responsible for deciding what targets all 3 legs of the U.S. nuclear triad would go after. And I had an unnuclear project, and I coined the phrase of using GPS and other high accuracy techniques to target critical components in basically target sites, so you can disable a target without having a lot of collateral damage. So this whole idea of non-nuclear strategic weapons technology is something that had its genesis when I was there at SAC. And from there, my next assignment was at the Edwards Air Force Base, working on the B-2 bomber as a flight test engineer. I was the first flight test engineer assigned to that aircraft by Strategic Air Command. Around this time, I think I felt like, I worked on a lot of major systems, I've been there, done that. I was looking for something new. I started burning out, but I had a number of projects that I was working on at the time, and I requested my separation from active duty. They all fell by the wayside. I got delayed. So I ended up separating the Air Force without a job and a family of 5 to support. So it was really tough. I connected with the Jet Propulsion Lab. Was hired back there as the fall protection engineer on the Cassini mission. And that was a very prestigious position because I was responsible for making sure that if there were any faults, anything going wrong with the spacecraft, that we had backup systems in place so we wouldn't lose that mission. And that was great. I continued all of this time. I was tinkering and working on my own ideas. In fact, it was at Strategic Air Command in Omaha is when I built the first prototype for the Super Soaker water gun. And it took obviously quite a few years from that point to when it was successfully commercialized. But it was that was basically an overview of my professional career.
That's fantastic.
Thank you, Dr. Johnson, for your service, for all your contributions to innovation, and then also the giving back part with FIRST and other programs that you're supporting. Again, innovation both on this planet and on others. So thank you for those contributions. And that's the perfect transition to our Innovation Station segment.
Innovation Station.
We're all anxious to hear a little bit more about the Super Soaker story. In a nutshell, how you came up with the idea. And again, thank you, because that was a big part of my childhood.
Well, Super Soaker, from my perspective, was kind of a stepping stone, if you will. I was working on a new type of heat pump that would use water as a working fluid instead of Freon, because I had this long-term concern about the environment. And so I thought, what could be better as a working fluid than a heat pump than water? So I was experimenting with some nozzles and things that I machined, and I shot this stream of water across the bathroom. This was my at-home project. I had a little Unimat lathe and mill that I could use to make parts and things. And so I was trying to address an environmental challenge when I got the idea for the water gun. And at this point, I had several patents, had experienced a lot of setbacks in trying to get things commercialized or get investors and so forth. So I said, I could come up with a toy and get some money from the toy, and that way I could support myself and then move on to my other inventions and ideas that I want to work on. So Super Soaker, it took a lot longer than I anticipated. When I got the idea, it was 82. It wasn't until 10 years later, 92, that it became successful. It was actually on the market, and it became the number one selling toy in the world. That has provided me revenue and allowed me to pursue my primary passion, which is addressing environmental challenges that we're facing. At this point, I'm developing a solid-state battery. I started working on solid-state batteries long before other people got interested in it. I started back in 1998 with a license from Oak Ridge National Laboratory for solid-state thin film batteries. They used glass electrolyte. There was no hybrid, no liquid electrolyte. And I had done an analysis and found that it could hold those, at that time, 4 times the energy of lithium ion. So I determined to develop the technology. Literally, this was over now 25 years ago, long before other people started thinking about solid-state batteries. But I figured that I could develop the technology, get working sales, get the intellectual property in place, and then wait on the industry to realize that solid-state would be the next big thing. So we've arrived in that. We have a very good patent position on solid-state batteries. It obviously has taken a lot longer than I anticipated to develop the technology, but we've come up with a proprietary glass electrolyte that is ideal for suppressing dendrites, very good conductivity, low-cost manufacturing, and we're continuing to refine that technology. Now the industry is looking for solid-state batteries. All the majors are working on it, but we have, I think, based on everything I've learned about what other people are doing, I'm convinced that we have the best solution. Also working on the next generation beyond that, lithium-air batteries. Again, something that problems that other people have tried to solve. We've been working on that for close to 25 years as well. We started, I think, in 2004 timeframe working on lithium-air batteries, and I maintained a pretty concerted effort, sometimes more effort into it than others, depending on resources available, but working, had a large team at some points, and other times very, very small team, depending on what the situation. But we maintain the effort. We've gone down a lot of empty rabbit holes and found all the ways it don't work. But now we have a system that we're very excited about, and we're getting ready to send some initial sales out for independent testing. And then after that, we'll continue to refine the technology and then move on in commercialization. Along the way, I came up with the idea for JTEC, which is like the Johnson Thermal Electrochemical Converter. It converts heat directly into electricity. It's a new type of engine that's more efficiently than the existing engine. And the real advantage of it is its ability to work on low temperature heat sources. So there's a lot of waste heat in the world. Our ability to convert heat into power is very inefficient. And this gets back to, all the way back to those days at Savannah River Laboratory on those nuclear fuel spheres, and even Galileo and Voyager, all of those spacecraft use these heat sources, and the technology for converting heat to electricity has been a major challenge. So we have that technology that's been spun out as a separate company. So both the battery and the JTEC are separate independent companies now, and I'm excited about where things are going.
I appreciate that perseverance through those 10 years, because I was born in 89. And so you made the 90s a little more exciting for me. And all the work you're doing now is making even greater contributions to our planet and our future. So appreciate that. And as I go around and I talk to students, I think that perseverance, you mentioned something also. We found out what didn't work, kind of continuing on that process, staying curious and continuing working towards your dreams or your vision, I think is very important, whether that's our college students in ASME programs or younger students is, starting out with first Lego League. I think that's key. So what motivates you to stay in the lab consistently? And how can we share that with some of the listeners as to how they keep that motivation to keep wanting to go after new inventions? And then after that, if you could share maybe which one you're most proud of.
Well, if I had to identify one thing that drives me, I would say it's curiosity. Even when I think back when I was a kid, taking toys apart, taking other things apart, appliances apart, looking inside to see how things work. It's just this curiosity. It's fascinating. And to me, engineering is like literally mind over matter. You envision something working, and I can envision all these moving mechanical parts. I was fascinated with the electronics because you can't see the electrons. So how do you figure out how to design? So I took a lot of classes in electronics when I was in college. And so being versatile and being able to really bring those technologies together is what has allowed the JTech to become a reality. For example, the battery is electrochemistry. The JTech, the heat engine, is electrochemistry plus thermodynamics, and it really brings it all together. It really is an engine with no moving mechanical components, and so it's just fascinating in the fundamentals of it, and fascinating even in the performance, because like I said, we can do things that other engines can't do, particularly efficiently operating on low temperature heat sources. It turns out that about all the energy sources that the U.S. relies on, the Department of Energy publishes this. I think Lawrence Livermore actually publishes it, but they talk about all the energy sources that the U.S. relies on, and they go across and show where, in this one diagram, where all those energy sources, what they support. There's, turns out most of the petroleum, as you would expect, goes into vehicle transportation. A lot of natural gas, coal. Nuclear goes into power generation and so forth. But on the right side of the chart, when you get all the way to the right, it shows that close to 65% of the energy available in those sources gets rejected as waste heat. Only about 30% is actually does useful stuff. And so my mission has been to try and flip that, improve the efficiency, being able to use more of that low temperature heat, so that we can actually have 60% of the energy go to useful stuff and do actual work, and reject 30% waste heat. So that obviously is a great challenge. We've taken it on. We're having great success in terms of demonstrating the technology, as well as improving on it and refining it. So curiosity drives me more than anything. Is it possible? Another example, even in the toy industry, when Super Soaker became successful, the other toy guns that were on the market were the Nerf dart guns. And I said, geez, I wonder if I could be the king of all toy guns. And so that was a nice challenge. And so I started redesigning Nerf dart guns and took them to a whole nother performance level, presented that to Hasbro and got a license. And I would say that between N-Strike and the Super Soaker, N-Strike was a category under Nerf, and I was insistent that, that would be, I wanted my own subcategory under Nerf. Between N-Strike and Super Soaker, I'd say close to 80% of the toy guns sold in the world were probably based on my patents at that point. So the idea of taking on a challenge and being curious and wondering if I could really pull it off successfully. So what I'm doing now is just taking on bigger challenges. There are even harder problems. Can I solve it? We'll see. It really is a matter of challenging myself.
I'm encouraged. I'm glad to hear that. A normal person would just say, I'm done. Let's call it a day. I'm over. It's over. So, but hearing where you are in the lab, as an engineer, I have to ask you, what do you think of the future of engineering?
When I look at an airplane flying in the air, and this big, heavy metal thing, and all this energy and power and everything, and it's very obviously, the Wright brothers could not imagine jet aircraft. They could not imagine supersonic flight. It was beyond, just beyond their comprehension that such a thing could be possible. And when I look at where we are now, when I talk to kids, I tell them, I would love to be your age so I could see all the fascinating things that people come up with and where technology goes. And particularly now with AI and what's coming online. And that's intriguing too in itself, because it's like, to me, back when we learned to write and read, we developed an ability to store information outside our brain, be able to retrieve information outside of our brain. Now we're able to problem solve outside of our brain and even create outside of our brain. Who knows what that's going to lead to? It's just fascinating, and my curiosity gets the best of me. I may just live a few years longer than normal because I'm so curious to see what will come. Really, really excited about that.
We're going to have to find a way to get you some glimpses of the future in that space, and maybe leave some tips and advice for those that will be tackling those challenges we see in the future.
I think the bigger challenge is, the age-old problem of getting along in the world. People understanding that just because people look different, or they're in a different place, or they, have a different religion or whatever, that doesn't mean that they're your enemy and that you gotta destroy them. And to me, figuring out how to prevent disinformation and propaganda and the destructive ability that we have as humans we can be very constructive, but we can also be very destructive. And so, to me, that's the bigger challenge. We'll problem solve, we'll move technology forward. And that's the other thing I tell kids when I'm talking to them. Creativity and problem solving is what human beings are built to do. We do that better than anything. Sometimes I'll use a rock and a cell phone, for example, 400,000 years ago, or a few 100,000 years ago. No, I think it was like 2 million years ago when we picked up our first tool. It was like a rock, stone, it's a hand tool. And now our hand tool of choice, of course, is a cell phone. And so I asked the kids to see, the rock and the cell phone have a couple of things in common. And I asked them this question, what do you think those two things are? And sometimes they come up with the answer. One of them is that they are both made from minerals of the earth. They're basically the same materials: the rock, silicon oxide, cell phone, silicon oxide, metals from the earth. The other thing that they have in common, when I was telling my son, for example, when I was talking to him about this, he says, "Yeah, there's another thing that they have in common, Dad. You can send a message with both of them." So anyway, but the human brain is what it took to turn rocks into cell phones. And we'll continue to push technology that way. And so the idea of problem solving, the idea of, well, should we do this or should we do that? We will move technology forward. That's not gonna stop. The question is, can we do it in a way that is altruistic? Can we do it in a way that's really mutually beneficial to us as human beings? And all bets are off in terms of how far we push technology, happen in the future, and what our abilities will be, and even interstellar travel, all of these things that we envision. Leonardo da Vinci envisioned human-powered flight 500 years ago. The technology to do it didn't exist. So we envision things now that we don't know how to do yet. But I think the idea that a vision will span generations and eventually come to fruition is, to me, very profound.
I think it's very impressive how far we've come, but even more inspiring how far we can still go, especially if the young people listening in today take some of your advice around staying curious. But before we let you go, I need to know, with all this time you spend on inventing and dreaming up ideas, do you have any actual downtime? And if you do, what do you like to do during that time?
My hobby became my job. So in terms of downtime, I enjoy what I do. you know, and you know, for a long time, you know, I talked to guys, you know, I pay to come to work. And I pay to have a team of people around me that I can bounce crazy ideas off of, and they can tell me whether I'm full of it or not. They tell me sometimes, well, you do all these fancy things in PowerPoint and we have to turn it into reality. But in terms of downtime, of course, obviously, I enjoy my family. I'm fortunate in that my kids, my older kids, work with me. My oldest son is a engineer. He's in fact the CTO at the energy conversion company, the JTech. Very sharp guy. Sometimes I'm talking to him. He looks at me and says, like, Obi-Wan, you were the master, not I am the master.
I love that.
So he challenges me, which is cool. I like that too. So it's cool. In terms of, I like to party. I like to dance. I like to go to, you know, I go to Mardi Gras from Mobile. So we have Mardi Gras Mobile every year. I do things like that. But I'm basically a homebody. I'm pretty content in that way. I don't feel like I'm missing anything in the world. I've got to get out and do something because I feel like I'm trying to make an impact and trying to use my life in a beneficial way. And because I feel that it would be a waste to squander the gift and opportunity that I have.
That's great, Lonnie. I tell you, I've really enjoyed this. And when you started out, I knew this was going to be a great conversation because I have my dad's erector set still, and it's just about 100 years old.
I just dug out. I have a storage room here, and not storage room, a storage building. It's a work, you know, it's a metal building. It's basically open, but the Unimat that I used to make the original Super Soaker was sitting over there. And I just had some guys go over and get it, clean it up, because and I look at the lab now and all the things that we're doing, but that Unimat, the little jeweler's lace, is what made it all possible. And it's, you know, I think I'll use it as leverage. These guys we've got a full-blown machine shop, you know, with Haas, and we can do 3D printing, we can do full programming, 3D machining, and so forth, metals and steel and all these materials.
I have a dear friend who's very successful in the timber business, and when he created the first sawmill that used instead of a circular saw blade, a bandsaw blade, because the bandsaw was a lot thinner than the circular saw, and you had more material out of each log. And the way he created it, he spent hours building this on his kitchen table with an erector set, and it's okay. Now I'm ready to have it put together. So I can tell you story after story, and we just bought a couple of 3D printers for the house here, so that my wife said to me, "What do we need those for?" I said, "We don't need them. I want them. That's a difference." And everything I look at now, yeah, I can print that, so it works. Thank you, Autodesk, for making my life a lot better, and it's a lot quicker. So, but hey, Lonnie, thank you again. Jay and I will have to come down. I'm anxious to sit there. Jay, we'll have to bring a super soaker so we get him autographed. Okay. So with that, ladies and gentlemen, until next time, I'm Tom Costabile on behalf of Dr. Lonnie Johnson and Jay Flores and the team at Unconventional Engineering. Take care, and we'll see you again soon.